Excellent. And we are back live. Some technical difficulties. I wasn't able to properly set up the stuff that I needed today, yesterday, because yesterday I was out of school, which was yay, being out of school. But yeah, I had to get everything done this morning, so it was a little bit of chaotic, but we're back and we're here and it's all good. So for those of you in the live chat, if you would be so kind as to, if I can actually get to YouTube real quick, there we go. If you'd be so kind to leave a comment in the chat, I should be able to update attendance, but apparently Genesis is down. But we'll see what happens. Okay. As for today, today is kind of twofold once again. We are here for the full 80 some odd minutes for that quote unquote intervention period and whatnot. My main goal for today is to be focusing again on the four-color theorem. Now, for those of you that are here today in the classroom, congratulations, you get to use colored pencils today. For those of you that are at home, unfortunately, I cannot give you colored pencils to use today, but some of the examples that I have, I'm going to be able to post into the Google Classroom so that if you have the capabilities of doing so, you can print that sucker out and you could follow along as long as you have stuff to color with, whether it be markers, crayons, or colored pencils, etc. But that's my main goal for today. A couple of reminders. Number one, you had a project due today. That project is not due until 2 p.m. So for those of you that have been working on it, obviously I gave you a huge head start last week, but obviously it's not due until 2 o'clock today. So email me if you have any questions and we can figure that junk out. I had mentioned on Tuesday that I wanted to do an assessment on Euler-Hamilton, and I still plan on doing that. On Tuesday, we reviewed Hamilton-Euler using that quizzes, and of course, you could always review Hamilton by doing the project as well. But I do have an assessment that I am going to be posting much later today. It wouldn't be due until next week, early next week or something like that. But as I mentioned on Tuesday, I'm going to be posting that assessment, so be on the lookout for that. I'm not going to interfere with the project. Projects do it too. We'll let you get that thing done. Okay. Let's see what we got here. Good. Okay. So what I'm going to do now, I want to give you an activity just to start with. And what I'm going to do is I'm going to post a PDF into the Google Classroom stream so that those of you in the live stream can see it. For those of you that are here, I'm going to give you an actual physical copy of the paper that I am referring to. Let me break this thing out, and I'll be able to show the live stream so they can know what PDF that they're looking for. But the PDF that you should be looking for is something that looks like this. It has 2 pages. You'll see it in maybe about a couple minutes. It has these 5 images on it that you guys are going to be working on partially throughout this class period. So let me get this thing posted, and then they can see what the heck is going on here. Let's see, duplicate. Add file, browse, should be right about here. Yes, so this should be the PDF for today. Post that sucker. Chapow. There we go. Yep, and there's that PDF for today. Now, like I said, for those of you that are on the live stream, unfortunately, I can't physically give you colored pencils, but you can use whatever colors you have around you, whether it be markers or crayons or colored pencils. If you have the capability of printing this out, that would be nice. Obviously, if you don't have the capability of printing this out, a couple of these images you would be able to color in and draw and whatnot. Now, we've done a couple of these already. The United States is going to be the big one for today. But the one that I want to focus on right now is this image right here. It is on the bottom of the first page. Now, we did this one last time, but I want to show you something very, very fundamental on this particular image. The instructions that I gave those of you here today, I told you to pick out 5 colors. One of them has to be black. Now, what you're going to do is you are going to use the other 4 colors, not the black one. You're going to use the other 4 colors to color this picture by the rules of the 4-color theorem. Meaning that, I don't know, if you picked red for the middle, that means that any area that is bordering red cannot be red. Red cannot share a border. Ultimately, you are going to end up using all 4 of those colors, but don't use black, and kind of fill that thing in. Now, I'm going to try and do the same thing with the colors that I have here. I have 4 non-black colors. Let's see how well I can do this while you guys are working at your desks. For those of you that are, again, in the live stream, like I said, this PDF is available to you. Unfortunately, I can't print it out and hand it to you. But if you have the capabilities of doing that, yay. If you could, I mean, obviously. But otherwise, there's the link for it, just in case you can't get to the Google Classroom stream. Let's see here. I don't want those colors. Yeah, the screen's kind of dead on it, whatever. Yeah, we'll use it anyway. Okay. I'm going to do the thing right there. Can't do the green there. I can't do the green there. Okay, so green is gone on me. All right, let's try orange. You know, during the pandemic lockdowns, one of the things of business that actually like spiked was the sale of coloring pages for adults. Because apparently, like during the pandemic, people were getting so bored. Well, people who didn't have kids, and they would be, doing these adult coloring pages, I guess, for some reason. I don't know, it's weird. There, only used 2 colors so far, so far so good. That's just me. Okay. And I can't do orange there. I can't do orange there. I can't do orange anywhere. I'll do a pink purplish. Right there. There we go. And then I'm going to have to use red up in here. And on the outside as well. There we go. Now, I am going to be putting some pieces of information. I am going to be putting some pieces of information into your notes shortly. But I wanted to talk about this coloring scheme. Now, obviously, your coloring scheme looks different. You use different colors. You pick your own colors. But I told you not to use black here. You do have black, and I wanted you to have it for what I want to do next with this thing. Now, what's going to happen in our notes is we're eventually going to be using these colored pencils in our notes as well. It's going to be nice. But basically, you could take, and this is where you're going to use your black colored pencil. You could take an image like that. Now, that's that region. I'm just giving it a vertice. I'm giving it an open vertice because when we do put these into our notes, I'm going to draw it like that with the colored markers, I should say. But this region is directly connected to this region. They share a border. And it shares a border with this region. And it shares a border with this region. And for the sake of argument, I'll just put it up here. It shares a border with this region. I'm just dealing with that one particular region right now. What I'm trying to do is I'm actually trying to map out a network of how the borders all interact with each other. This particular region right here is bordering 1, 2, 3, 4 different other areas. And you can do the same thing with every region. For example, this orange region right here for me is connected to this purplish pink, this red, and it's connected to that green. And I can make all of those connections like that and make that network. I'm going to do the same thing with this red as well. This red up here is also connected to this green, so I just had to make that connection real quick. Boom, boom, boom. And then this orange is connected to all of these. This green is connected to all of these. And this orange is connected right there. There we go. It should end up kind of like a pinwheel, a slash. I don't even know. 1, 2, 3, 4, 5, 6, 7. It's actually a 7-sided shape right there. That's cool. Oh, I didn't make this connection. Here we go. I didn't make these connections. I got to make sure I put these connections in. There we go. Make sure I didn't miss any. Nice. Good. And the idea is that a vertice cannot have the same color or the same designation as a connected vertice. But what you're going to find in a little bit, what you're going to find from what we eventually map out about this whole thing, is that this network shares a similarity with another map that we're about to take a look at. There are multiple ways to look at these maps. There's 100,000 different ways to look at these maps. But if you look at the network, you can actually boil it down to its bare bones shape and connections. It's wonderful. Absolutely insanely wonderful. So here's what I want you to do. Obviously, you have this paper, and we're going to be coming back to this in a moment. But what I want to do is I want to copy down something into my notes. So if you would, if you do not already have them out, I'm going to need those notebooks out and open. Now, we're going to be coming back to this packet in a little bit. You will see. It's going to be great. For me, not for you, but for me. Let's get there. Bring this down. Now, I'm going to leave that image on the board, actually. Yeah, I am going to leave that image on the board, but I'm going to bring up my notes right here. There we go. It's frozen, like my heart. There we go. Cool, 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 cool. Bring that back. Boom. Zooming out, zooming out. There we go. So yeah, I can leave that image on my board. That'd be nice right there. It's just kind of sitting pretty for the time being. That's okay. Today is the 29th. Holy crap. Next week is May. This is the 4-color theorem. Let's see, put this up here. Put that down there. There we go. Good, 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 good. The theorem basically states, on a map, at most, 4 colors are needed to color if bordering areas cannot have the same color. On a map, at most, 4 colors are needed to color if bordering areas cannot have the same color. That, in general, is the idea of the four-color theorem. Doesn't matter what type of map it is. Now, what I want to do is, this is the circle example. I'll just put circle example in my notes. Can't really see that well, the word circle example. That's okay. I'm going to draw my stuff over here so you can see it. And what I'm going to do is I'm actually going to copy down that pinwheel vertice picture that I have on the board. I'm going to try and do this as best I possibly can. So there's 1, 2, 3, 4, 5, 6, 7 circles, or 7 vertices, I should say, in a row right here. So 2, 3, 4, 5, 6, 7. And then there's an 8th vertice up here. There we go. Now that vertice up top connects like this. There we go. I'm just copying down that picture. Everything kind of borders in this pinwheel. There we go. And then there's one in the middle that connects to all of them. Well, the ones in the circle, I should say. The ones that ended up being in the circle. There we go. It's a fairly straightforward image. I'm just copying it down. Let me go get my markers so I can actually color it the way that I have it on the board. And of course, in your notes, you can use those colored pencils as well. Let's see. In the middle, I used red. And up here, I used red. Again, you use whatever colors you drew on the picture. Let's see. I did orange right here. And orange right here. And orange over here. There we go. I did pink right over here. There we go. Pink. Yeah, it's pink. I'm realizing on the live stream, they all look very similar on the live stream, but they look totally different on the board. That's weird. Anyway, that was the only one I did with pink. Okay. And then the other 3 I did with green. There we go. Yeah, all I did was I copied down this image that I have to the left. But this is the network that I tried to employ. There we go. I used the colors that were on the board. You can see the green, but they came up kind of as different shades. That's weird. I don't know. I kind of like it, though. Weird. But yeah, this is the network of that image. This is what we call the network of the map. Now, they talked a lot about like detangling and stuff like that. I'm not going to get into the details of detangling today, but detangling is actually pretty sweet, whether or not something actually could be drawn as a map. It's a really interesting system, but I digress. Now, what I would like to do is I would like to compare eventually this image that we have to the image of Europe that you have on the second page. On the second page, and this is why I stapled them. I didn't know if I was going to use markers or colored pencils or whatnot at the time because I didn't know where my colored pencils were. But on the second page of this PDF, you have Europe. Now, don't color it just yet. Don't begin coloring it just yet. Don't begin coloring it just yet. Instead of coloring it just yet, what I'm going to do over each country, like Germany, I'm going to make a circle in black, and I'm going to suggest that you do the same. Make a circle for Poland. Make a circle for the Czech Republic. Make a circle for Slovakia, for Hungary, Austria, Slovenia, Italy, and Switzerland. Make a circle for all of them. Then, what I want you to do with the black colored pencil, I want you to connect the vertices if they share a border. So you actually do that now. You can do that directly on this little piece of paper. Connect the two countries if they share a border. See what it looks like. So for example, Germany and Switzerland, Switzerland and Italy, make all of those connections. Let's see here. I'm going to finish up my connections too. Slovenia, Austria, Czech Republic, and Slovakia, Hungary, and there we go, and Poland, Germany, Czech Republic, and Poland, and this one down here as well, and this one right there as well. What I would hope that you would see, is the fact that even though it's a little bit distorted, the image that I have on this partial map of Europe is the exact same. Oh, almost. I got to connect these. Germany connects to Austria. There we go. Good. But it's the exact same network that we drew originally on the board right there. I feel like I'm missing a connection. Did I miss a connection? No, I think I got all of them, right? Yeah. I had missed a couple before, but I fixed it. Yeah. Because Germany, Austria borders a bunch of countries. Austria, right in the middle, borders Germany, Czech Republic, Slovakia, Hungary, Slovenia, Italy, Switzerland. Yeah, and then Poland only borders the three up there. And then the rest of them kind of work in that little pinwheel fashion. It's the exact same image. So now what you can do at your desks on this little piece of paper thing, you can color in the different countries using the same exact color scheme, that you used before on that circle example. So for example, for me, I would make Poland up top red. Yeah, I would make Poland up top here red. Now, I don't know how it works with the colored pencils, but when I do this in red, you can still see the black over top of it. I don't know how it works for you, but does the black kind of show through? A little bit. All right, as long as it's there, but you can totally do it. And then I'm going to make Austria right in the middle. There we go. Make that one red as well. But it's the exact same map. I could make, now this is pink. I'm going to make Germany pink according to the image that I have there on the left. I'm going to make Germany kind of pink. I know on the live stream it may show up a bit like purple, or I hope it doesn't show up as red. That's a little better. Yeah. It didn't really show up as red. There we go. It's a little bit better that it's filled in like that, But anyway, and then orange, I can fill in the Czech Republic as orange. There we go. And Hungary as orange. And Italy for me is orange. And then I'm going to fill in the rest of them as green. It's really nice. Can you name two countries that are within the borders of Italy? Can you name two countries that are within the borders of Italy? Two independent countries? Naples? No. Sicily? Nope. That's a section of Italy. Yeah. Vatican City is its own independent country within Rome. And San Marino. Got to know your geography. Oh, I love geography. In fact, part of the thing that I wanted to do And you'll see this in a little bit. I actually wanted to try that geography guesser thing, but we'll get there when we get there. This is what I really wanted to show, was the fact that this map of Europe is exactly the same as the map that I just put into my notes right here. It just looks a bit different. It's really nuts. Now, a couple of rules to this, and these rules I'm going to have to put into my notes. So here we go. Let me go back to my notes real quick. Kind of figure this thing out. Here we go. Oh, I can erase that thing off the board now. Because now that I have it copied down a couple of times, it's kind of nice the way that this thing works. There we go. The subject of geography doesn't really have much to do with this per se. It's just kind of like one of those novelties of math. I have a little speech to kind of go with it, but I'll save that speech for a few minutes. Okay. So any map can be broken down to a system of edges and vertices, otherwise known in our cases as a network. As we saw, two different looking maps may have the same network. As we saw, two different looking maps may have the same network. What's really interesting is that when you create borders on a map in real life, there are an infinite number of ways that a map can look. However, even though there's an infinite number of ways that a map can look, there are a finite number of ways that a network can look. It's really messed up. That's partially how they were able to solve this thing, this four-color theorem back in the 70s. Before the 1970s, it was an idea. Yeah, at most you need four colors. It was a cool idea, but they weren't able to prove it until they had computers. And they were able to actually do every single stinking case in existence of a network. It was insane. It was great. It was wonderful. Okay. Now, do have a small challenge. A couple of small challenges, really. But I'm going to show you what that challenge looks like in a few moments. Now, the United States is not that challenge. The United States is not that challenge. The two examples that I needed from these papers, I needed that circle example, which obviously you have, and I needed the Europe example. The reason why I'm not going to have you color in the United States, I mean, you can if you want to, that's completely up to you. But the reason why I would not have you color in the United States is because of the website that I had you guys on last time. If you go back to the Google Classroom stream, there is this thing, transom.org. Again, you don't have to go to this right now. You don't. But they do have one with the United States. And it can get a little tricky. It can get a little tricky, but it is entirely possible. It is entirely doable. It's really fantastic the way this thing works out. Alaska and Hawaii really don't matter. You can make them whatever color you want. What's really interesting is the fact that I believe that you can actually color the water here. Yeah, you can actually color the water here, which is really funny to me, because they do count that. They do count that as part of it, which is like, what the heck, dude? I don't know, but it's just kind of cool to me. One of the things that I may end up giving you just as like a fun little assignment, not exactly right now, but something that I would give you as a fun little assignment is to actually do the United States thing, fill that out, take a screenshot, and then take a screenshot of the trophy that you get. Because obviously, if I checked it right now, scroll down. If I checked it right now, it wouldn't give me the trophy. It would just say, please continue coloring. With that coloring, it's a European thing. Yeah. Now, this is a weird theorem. This is a weird theorem where I thought about it, and I've thought about it, and I've thought about it, and I think I can figure out some abstract things for it, but I'm trying to think about applications. How in the world could this potentially apply to real life? It's quite insane. One of the things that I've learned in mathematics is that just because something seems useless, just because something seems like, oh, that's kind of cool, I guess, but like, how does it help the world? Just because something doesn't seem like it could help the world doesn't mean that it's not worth studying. For example, you guys know what a prime number is? What's a prime number? Basic definition. You mean divided? You said multiplied. Well, like, for example, give me an example of a prime number. 5. 5 is a prime number because it can only be divided by 5 and 1. That's actually the definition. A prime number is a number that can only be divided by itself and 1. 1 does not count as a prime number. It doesn't. It does not count as a prime number. It is considered to be a unit. 2 is the first prime number. There's 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31. It keeps going and going and going and going and going. Prime numbers are infinite. And prime numbers can be like, well, that's just kind of dumb. What's the point of prime numbers? There doesn't seem to, okay, but people have devoted their lives to studying prime numbers. People have devoted countless hours. People have received PhDs while studying prime numbers. People have received, not Nobel Prizes, because there's no Nobel Prize for math, but they've received high-level awards for studying prime numbers. But there's been no point. What's the point of studying prime numbers? There was no point. Mathematicians just loved them. They felt that, well, these seem important. But there was no real-life application until the 1970s. You ever purchase something online? Have you ever worried that somebody might steal your information? Right? Yeah. The reason why you can make a secure purchase online is because of prime numbers. There's this certain type of security system in place across the internet called RSA cryptology or cryptography. Combined with a couple other things, but the RSA cryptography at its core, its root core, is a prime number algorithm. And because of it, you can purchase stuff online without fear of having your information stolen. Unless they work around it through a different way of doing it. If you clicking an advertisement and then something pops up on your screen, or just random stuff like that. But prime numbers actually ended up having an application, but mathematicians don't care about it because we love the beauty in it. I look at something like this, like the 4-color theorem, and I'm thinking, what the heck is the application? There does not seem to be an application. But one day there will be. One day there will be. Just because you can't apply something now doesn't mean it can't be applied in the future. Oh, I love it so much. I don't know. The one thing about this map that I will say, a couple things, which I am going to have to put a note into my notes about it. First, if you do try this, Michigan, for some reason, I don't know why. I mean, I kind of know why. But Michigan is split up into 2 parts, so they count each part as something separate. But you can't really see it, but there's actually a waterway that goes through. So these 2 little parts of Michigan actually don't touch each other. You ever notice that Michigan looks like a mitten? Yeah. It just looks like a mitten. It's kind of cool. Anyway, but then also here is Lake Michigan. I think, yeah, this is Lake Michigan. So just to be sure, that's not actually a state. I don't know if they're going to actually have you color that in. But again, that's for another day. Let me go back to my notes real quick. There's a note that I want to make about vertices. Yeah, go back here. And come on. Here we go. If two areas only share a point, of border, it doesn't count as sharing a border. I'm going to show you an example of this in a minute. If two areas only share a point of border, then it doesn't count as sharing a border. It actually has to be like not a long edge, but an edge per se. I'll show you a visual example of this in a moment. I have to go back to that Transom website. But technically it doesn't count. And the way that I can show you that is right here with this squiggle example. With this squiggle example, I could make this blue right here. And I can make that blue and that blue. Come on, there you go. Blue, 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 blue. And you can see that everything that I'm filling in right here is only sharing a point, just a singular point with the other blue regions. And this actually does work. And the reason why I bring this up is because of the four corners of the United States. I'll make the rest of this yellow right here. Boom, yellow, yellow, yellow. And you can see they're only sharing singular points. I'll go up to the board in a moment and kind of show that. Come on. Boom, there we go. But technically speaking, right here, that's only sharing like a point of border, a singular point, which doesn't count as actually sharing a border. So if I went to do the check on this, it would give me the trophy. Let me actually do the check on this right now. Come on, you, all your coloring. Check. There it is. Claim your trophy for a correct color scheme. Let me claim my trophy right there. It's being polished. There it is. I got my trophy for the squiggle. And then, yeah, it keeps collecting my trophies simply because I did it. It's great. It's fun. What's the polygon one look like? Oh, the polygon one. Yeah, I'm not going to give that one to you just yet. Eventually, I do want to, I think it's this one. Nope, not that one, not that one. Where'd it go? I had a really cool one that I gave as like a little bit of a challenge one year for this class. Let me see if I can find it here. It should take me like 30 seconds because I think I know where to look. Archived, discrete. Let's see. There it is. There it is. There's a challenge that you guys will eventually get with this. This one's kind of fun for me. The question is, can you properly color the map using only 4 colors? Yes, you can. This map was actually really funny. It was posted in a journal called Scientific America. It appeared as an April Fool's Day hoax. Pronounce it. This guy claimed that this map could not be colored with fewer than 5 colors, thus disproving the 4-color theorem. But it was a hoax because in reality, you can color this with 4 colors. It is entirely possible. My suggestion that when you actually go about doing stuff like that, when you actually go about attempting to color in stuff on paper, let me zoom on this. You don't have to pick your 4 colors right away. Instead, what you could potentially do is you could label each section first with like a number, but assuming that you're only going to use the numbers 1 through 4, you'd be like, well, that's number 1 right there. And that's number 2 right there. And you can do this in like pencil. It might be easier to do this in pencil because eventually you may have to like erase and start again. But the idea being that, okay, well, I can do 3. Actually, I could have done 1 again. So I'll do 1 again here. I have to do 3 again here. I have to do a 4th color here because they all share right there. And then you can go from there. And if you fill it in all correctly and you're like, yes, I think I got it, then you can begin coloring this crap in the way that it's supposed to be. I believe that if you do map of United States images, I believe that no matter what image you actually end up picking, make this larger? Probably can't. I'm looking at the 4 corners right here. Yep, there's one example right there of the 4 corners. I don't know if you can see it right there, but 2 of the states are colored the same in orange. And none of them here, none of them here. They're both in orange here. Oh, that's a lot more than 4 colors. But typically, when you see a proper map of the United States, they try to minimize the number of colors. Oh, that's a bad one right there. Look at that. New Mexico and Oklahoma sharing the same color border. Oh, there's a couple with yellow. Yeah. Well, a lot of them will try to follow the 4-color theorem just because it looks more visually appealing to have your colors kind of spread out like that. Oh, the United States. Such an odd thing that we got there. All right, click. There we go. Okay. So what's going to happen is this. As I said, I am going to be assigning you a major assessment on Hamilton Euler, which obviously you've been working on that project. I'm going to be assigning that today, much later today. The next time we come in, which by the way, I know class isn't over till 8:43. I have plans. I'm just kind of wrapping a couple of things up. When you come again in on Tuesday, I mean, obviously we will try to continue with some activities with the 4-color theorem. Keep that in mind. Just the random stuff that I have planned. You'll see. But then I have like various activities. Like I am going to at one point kind of give you for like a minor assessment to actually color that big thing, that April Fool's Day hoax thing. I don't have it for today, but it's just kind of fun. I don't know. But yeah, that was my main goal for today. So with the time that we have remaining, I want to try a couple things. I can only try it a little bit because you actually have to have a membership to the website. But I did want to try that GeoGuessr thing with you guys just because I'm terrible at it. And I don't know if you guys have better insight than I do. But apparently you can only do like a certain like number of attempts per day if you don't have a membership or some junk like that. I don't know. It's a weird thing. But I did want to try that. But then once I'm kind of done with that, I am technically done with the live stream lesson for the day. Now, for those of you in the live chat, like I said, I am technically done with this live stream lesson for the day. If you still need to work on your projects, I would strongly suggest that you take the remaining time and do that because this class period does go till 8:43. Beyond that, like I said, I will eventually be signing that major today, and we will continue with some stuff with the 4-color theorem. So if you guys in the chat, if you have any questions, make sure that you are emailing me, but I am going to be signing off in a moment. And of course, if you have not left a comment in the live chat, please make sure that you do so as well. So I'll leave this open just for another moment. But yeah, that's technically my official lesson for the day. So yay. Cool. I'm giving them a moment to comment if they want to. And they're not, so I'm going to end the stream. There we go. Click. Haha, live